Vikas, are you able to hear me clearly? $354. Are you able to hear me clearly? LE2?
సార్ క్లియర్ గానే ఉంది సార్, వస్తుంది సార్.
బోర్డు కూడా క్లియర్ కనిపిస్తుందా?
కనిపిస్తుంది సార్.
ఓకే, రైట్.
ఆ లైన్స్ దాటి పైకి వెళ్ళింది సార్ కొంచెం క్యామ్. పైన లైన్స్ ఉన్నాయి కదా సార్, ఆ లైన్స్ దాటి కొంచెం పైకి వెళ్ళింది.
ఓకే, అది ఓకే లేదు. అది మనం రాసుకునేది పైకి రాసుకుంటాం అంతే కదా. కింద అంతా కింద బోర్డు మొత్తం కింద వరకు కవర్ అయింది కదా.
కవర్ అయింది.
ఓకే, కింద కూడా కొంచెం వస్తుంది. ఓకే, నో ఇష్యూ, అది ప్రాబ్లం లేదు. Okay, I think around 56 members are joined, right? Maybe 54. I think there is a small announcement. You need to provide the feedback for the first semester. I think all of you know there is a link in the college website. So you do that first. I think I'll allow you 10 minutes to fill that feedback. Then we'll start the class. So I think you are able to get what I'm saying, right?
స్టూడెంట్ ఇన్ఫోలోకి వెళ్ళాలా సార్?
కాలేజ్ వెబ్సైట్ ఉంది కదమ్మా,
ఎస్ సార్.
ఇంతకుముందు స్టూడెంట్ ఫీడ్బ్యాక్ ఆన్లైన్లో నాకు ఇచ్చింది ఇంతకుముందు.
లేదు సార్, కాలేజీలో ఇచ్చాం.
ఆన్లైన్లోనే ఉంటుంది చూడు, అది మళ్ళా యూ డూ ద సేమ్ థింగ్.
ఓకే సార్.
ఒకసారి లింక్ ఓపెన్ చేసి, అంటే ఇప్పుడు అది ఓపెన్ చేయాలంటే ఇది డిస్కనెక్ట్ అవ్వాలా? ఓకే, సో అడికి ఆల్రెడీ వచ్చింది చూడండి, అందరికి వచ్చి ఉంటుంది నేను అనుకోవడం. వాట్సాప్లో కూడా లింక్ వచ్చి ఉంటుంది, వెరిఫై చేయట. రోల్ నెంబర్ 6 పెట్టాడు ఆల్రెడీ, ఆ లింక్ పెట్టాడు. మీకు కూడా వచ్చి ఉంటుంది వాట్సాప్లో. మీకు ఇన్ కేసు ఎవరికైనా రాలేదంటే వాట్సాప్లో ఇంక లేక ఇక్కడ ఆల్రెడీ కామెంట్ చాట్ బాక్స్లో ఇక్కడ పెట్టాడు రోహిత్. సో యూ కెన్ యూజ్ దిస్ లింక్, ఫీడ్బ్యాక్ లింక్ అని ఉంది కదా ఇక్కడ. జస్ట్ దాని మీద క్లిక్ చేయండి చాలు మీరు. సో ఇక్కడికి వస్తుంది, మీ రోల్ నెంబర్ రాసి యూ నీడ్ టు సబ్మిట్ ద ఫీడ్బ్యాక్. సో మేబీ మై స్క్రీన్ ఈజ్ నాట్ విజిబుల్ టు యూ. Okay, so I'll show it that. Later I will disconnect this. I think now you are able to see my screen. See, if you click on that link, whatever link you provided through that WhatsApp, you will direct it to this page in the college website. Just you need to enter your roll number and click submit. I think then feedback entry form may open. Like let us say, I'll type one number, I'll check it. Okay, 18501 A036. 18501 A0306. Not working. 18501 A0306. Yes. So if you click on that now, you will get all the feedback section. So in that feedback section, you need to select the scale. So scale is also there in that. Just you pick your feedback. Okay, I am closing this now. So we do that within 5 minutes so that we can start our class. Okay. I think now you have done that. So then we'll start the class. Is it over? Feedback? I think most of you done that. I hope so. So, hmm, so okay, right. So we'll move on to our class. Okay, there is some problem with this mic. Not turning on. Like this. Okay. Right. So yesterday, I have given one problem to you. Maybe I hope you might have solved that problem. So today we'll take up one more problem. That is another new problem. So we'll try to discuss this, and then with this we close this topic also. This problem is on combined stresses. So far, whatever we discussed in those problems, you have either axial load, or you have bending load, or you may have torsional shear stress. Like that. Whether it may be finite life problem or infinite life problem, but there is only one stress. Suppose you have a combination of stresses, that is, it may be combination of bending load and axial load, or it may be a combination of bending load and torsional load. How we can solve the problem? So, for that, we will consider a problem which is having both bending and twisting loads or torsional loads. So, then how we can design this problem? So, the procedure is similar. Only thing is the calculation of mean stress and amplitude stress is going to be different. So, that is the only thing here you need to learn from this problem. Okay, right. So now first note down the problem, then I will discuss the solution. A transmission shaft, a transmission shaft carries a pulley, a transmission shaft carries a pulley midway between the two bearings, midway, MID, midway between the two bearings. Full stop. The bending moment at the pulley, the bending moment at the pulley where is from 200 Newton meter, from 200 Newton meter to 600 Newton meter, to 600 Newton meter, comma, as the torsional movement in the shaft, as the torsional movement in the shaft where is from 70 Newton meter, from 70 Newton meter to TO2 200 Newton meter, 200 Newton meter. Full stop. The frequencies of the frequencies of the variation of the frequencies of the variation of Bending moment and torsional movement are equal. The frequencies of variation of bending and torsional moments are equal. Bending or torsional moments are equal to the shaft speed. To the shaft speed. Full stop. The shaft is made of steel. The shaft is made of steel Fe 400. The shaft is made of steel FEE. One more E, capital E is also there. Capital F, small e, capital E. Then 400. FEE 400 within the brackets. SUT is equal to 400 Newton per mm square. And SYT is equal to SUT is 540, not 400. You make it 540. And SYT is 400 Newton per mm square. Close the bracket and full stop. SUT 540 Newton per mm square and SYT 400 Newton per mm square. Full stop. The corrected endurance limit of the shaft is 200 Newton per mm square. The corrected endurance limit of the shaft is 200 Newton per meter square, mm square. Full stop. Determine the diameter of the shaft. Determine the diameter of the shaft using a factor of safety of 2. Determine the diameter of the shaft using a factor of safety of 2. Okay, that is the problem. I'll read the problem again. Just so if somebody missed out, you can note it down again. A transmission shaft carries a pulley midway between the two bearings. Full stop. The bending moment at the pulley varies from 200 Newton meter to 600 Newton meter, as the torsional moment in the shaft varies from 70 Newton meter to 200 Newton meter. Full stop. The frequencies of variation of the bending and torsional moments are equal to the shaft speed. Full stop. The shaft is made of a steel FEE 400 within the brackets. SUT is equal to 540 Newton per mm square and SYT is equal to 400 Newton per mm square. Full stop. The corrected endurance limit of the shaft is 200 Newton per mm square. Full stop. Determine the diameter of the shaft using a factor of safety of 2. So this is the problem. So in this problem, one important point what you need to remember here is, so he has given the statement also in the problem itself, that is, the frequencies of variation of bending and torsion moments are equal to the speed of the shaft. If that condition violates, if it is not satisfied that condition, then you cannot solve this problem, because if the shaft speed is different and the variation of bending moment and the twisting moment is different, then what happens is you cannot estimate correctly what is the mean stress and what is the amplitude stress, because both are having different magnitudes. So whenever the bending moment is maximum or minimum, if the location is also same, that means the shaft speed also same, then only you can solve the problem. Okay, right. So of course that is the important condition. Suppose if it is not mentioned in the problem, we will assume like that. If it is not mentioned like that, we need to assume whatever it may be, whether it is bending load or twisting load or maybe any other load. So for all the loads, the frequency should be same, and the frequency should be equal to the frequency of rotation of the shaft. If it is a rotating shaft, suppose if it is a stationary shaft, there is no issue. But only thing is the frequency of the combination of loads what the shaft is subjected to, those two frequencies should be set. So then only you can club. So here I have twisting moment and bending moment. Both are varying, but the varying frequency should be same. Then only I can club the effect of those two. If bending moment is having different frequency and twisting moment has some other frequency, means we cannot solve the problem. Okay, so whatever they whether you mention the problem or not, we'll assume like that and we'll proceed for the solution. So now to come to the solution for this problem here, like I already mentioned here, two kinds of loads are there. One is bending load, other one is twisting load. So because of bending, you have a normal stress sigma. Because of twisting, you have a shear stress, that is tau. So if these are acting on the component separately. That means if there is a only bending moment or only twisting moment, we solve those two kinds of problems. So we have taken two examples. In those two example problems, maybe first one is the only bending moment is there in that. In the second one, only twisting moment is there. So we are able to design that if they are separately acting. So where bending moment is acting separately or twisting moment is alone acting on the shaft, where our component, we are able to design that. So now, when both are acting, then what you need to do is, so either you need to convert the effect of bending moment and twisting moment into either equivalent normal bending moment or equivalent twisting moment. So that means we know the procedure how to solve the problem when a component is subjected to only bending moment, or we know the procedure when the component is subjected to only twisting moment. So, but here in this particular problem we have both bending moment as well as twisting moment. Now, in order to solve this problem, what I will do is, if it is possible for me to convert these two, that means a combination of bending moment and twisting moment to a equivalent bending moment. So that means, so I am replacing the effect of bending moment and twisting moment by a bending moment itself. So that means it is similar to the first problem what we solved. That is, now if I convert, that means I am replacing this bending moment and twisting moment by only one moment. So we know the procedure how to solve this problem. Similarly, instead of bending moment, equivalent bending moment, I can convert this one into equivalent twisting moment also. I can convert that one into equivalent twisting moment also. That means I have only torque. That means because of the T equivalent, you have only torsion shear stress. So we know the procedure how to design for that also. Right? So that means what we need to do is, even though there are two things, two loads are there, two loads acting simultaneously here, if you are able to convert that one into a equivalent single load, either bending moment or either twisting moment, then we are able to solve that problem. But now the next question is, how we can convert these two into a single, either a single equivalent bending moment or single equivalent twisting moment. That is the next question. So how will you do that? Do you have any idea? So I think maybe long back, 5 to 10 classes back, we discussed about static failure theories. In those static failure theories, so we discussed about the combined loading, all these things, right? So how we can design a component when it is subjected to a combination of load under static conditions. Under static conditions, there we discussed about especially three failure theories. Those are, what are those three? Are you able to hear me?
Yes, sir.
Okay, right. So nobody is responding. That's why I have a doubt. My doubt వచ్చింది. ఎవరు రెస్పాండ్ అవ్వబోతుంటే మైక్ పని చేస్తున్నా లేదని డౌట్ వచ్చింది. ఓకే, రైట్. So then you tell me if you are able to hear me. You tell me answer my question for my question. What are the three failure theories we discussed in case of static failure or elastic failures? ఒరే ఇంకా గుర్తులేకపోతే ఎట్రా బాబు, రేపు మిడ్ ఎగ్జామ్స్ వస్తున్నాయి కదా నెక్స్ట్ వీక్ నుంచి. If you are not able to recall those things means it is difficult thing to, you cannot write the mid examination also properly. So maximum normal stress theory, maximum shear stress theory and discharge energy theory, right? Discuss చేసావా ఇవి అది కూడా గుర్తులేదా?
ఎస్ సార్, చేసాం సార్.
So when you go for maximum normal stress theory, only in case of brittle materials, if you go for maximum normal stress theory, so maximum shear stress and discharge energy theories are will use for ductile materials. Again, in those two, we assume that not only we are not it is not assumption, it is fact. So discharge energy is going to be the most accurate when compared to the maximum shear stress theory. So that means, so we'll use discharge energy theory here also to convert this into either equivalent bending moment or equivalent twisting moment. That is one way of solving the problem. Other way is, whatever stresses are there, so because of this bending moment you have a normal stress sigma is there, because of the twisting moment you have a shear stress tau is there. So now if I have a normal stress and a shear stress, I can find out what is the equivalent von Mises stress using that discharge energy theory. If I am able to find out that equivalent von Mises stress, which is also in the form of a normal stress, then I can solve the problem. So that means two ways you can solve the problem. Like I mentioned earlier, you take these two, try to convert this bending moment and twisting moment into either equivalent bending moment or equivalent twisting moment. If you have only equivalent bending moment, then you have only normal stress. If you are converted into the equivalent twisting moment, you have only torsional shear stress. So now we know the procedure how to divide the component for the torsional shear stress. In the previous problem, I think in the previous class we discussed that problem. So this is one way of solving the problem. Other way is same thing, but I am saying that two ways. So two ways means they are same only, but only thing is substitution of equations are we are doing in a different manner. So instead of converting M equivalent and T equivalent, I will convert the stress values into equivalent normal stress. I will convert the stress values into equivalent normal stress. So now, what is the formula for our von Mises stress? Sigma von Mises. So we derived this during while studying about the static failure theories. So whenever if I have, see here, I have one bending moment and one twisting moment is there. So if you have one bending moment and one twisting moment, because of the, if you substitute that you have a bending stress sigma x, I'll take it as bending stress, and tau xy is the shear stress. Let us if I take like that, then the formula for your von Mises stress is sigma x whole square plus 3 into tau xy square. Tau xy square. So under square root. So I need to use this formula. So if you have any doubt how we got this formula means, so you go back to our equations, whatever we derived it, that is your von Mises stress, sigma von Mises is sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. So under square root. This is what we derived in the case of our biaxial state of stress. If it is triaxial state of stress, we have sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 into sigma 3 minus sigma 1 whole square. So that is a different thing. In case of biaxial state of stress, this is the formula for your von Mises stress. Now if you substitute for what is sigma 1 and what is sigma 2 in this, if you simplify this, you are going to get this. Of course, actually what I thought is, I might have given this one as an exercise for you. Derive the von Mises stress in this form, provided you have sigma x and sigma tau xy is present in the missing component. Maybe I forgotten that. Anyway, it's not this. Now also, if you want, you can check, use this formula to derive this. You have only sigma x and tau xy is there. So first identify what is sigma 1 and sigma 2. If you have sigma x and sigma y, tau xy is there. Then substitute into that and try to simplify that. Check that whether we are getting this one or not. Okay, anyway, so this we are going to use for this problem. For this problem, we are going to use this. That means, first I need to compute what is the bending moment, and what is the stress due to twisting moment, tau xy. So for that, again to do that, here we have two values. Your bending moment is not a constant bending moment here. It is a varying moment, varying bending moment, as well as your twisting moment is also varying. It is not constant. So therefore, whenever there is a varying load, you need to calculate what is mean and what is average. Amplitude, not average. Average, mean, and both are same. What is the mean load and what is the amplitude of the load? So you need to compute that. So first I'll calculate mean bending moment. M suffix M, capital M for bending moment and small m is for mean value. So what is the formula for this? Maximum bending moment plus minimum bending moment divided by 2. That is the mean. Mean nothing but average only. Average of those two. So what I get here? Maximum is 600 and minimum is 200 divided by 2. So which is 400 Newton meter. 400 Newton meter. Similarly, I'll compute the amplitude of the bending moment. So the formula for that is maximum bending moment minus minimum bending moment divided by 2. So which is 600 minus 200 divided by 2. Which is 200 Newton meter. Then similarly, I'll compute T mean, that is mean torque or mean twisting moment. T mean is nothing but same formulas, T max plus T minimum divided by 2. So T max given it as 200 and T minimum is given as 70. 200 plus 70 divided by 2. 270 by 2 means it is 135 Newton meter. Similarly, what is T amplitude? So that formula for T amplitude is T max minus T minimum divided by 2. It is nothing but 200 minus 70 divided by 2. So 130 by 2 means it is 65. Okay. Right. So now I have mean bending moment, I have amplitude of the bending moment. Similarly, I have mean torque and amplitude of the torque. So now I will calculate the stresses due to this mean bending moment and mean amplitude of the bending moment. And because of Tm, what is the torsional shear stress? Because of Ta, what is the torsional shear stress? So for that, you will use your bending equation and twisting equation to find the stress values. Suppose I'll find out sigma m. So sigma m is nothing but the normal stress due to mean bending moment. So what is the formula for that? Mean bending moment divided by Z, where Z is the section modulus. So here we don't know the diameter. We have to compute the diameter of the shaft. D is unknown for you. So we take that the section modulus also in terms of the unknown D. So if I substitute that here, what I get? Mean bending moment is 400 Newton mm. So here what I do is, I'll assume I'll get D is in mm. First, I'll assume that D will be in mm. So therefore, I need to convert this 400 Newton meter into Newton mm. So for that, I need to multiply this one by 10 cube divided by, what is Z for a circular shaft? 5 by 32 d cube. 5 by 32 d cube. So I'll get sigma m value. Similarly, I'll compute sigma A. Sigma A is nothing but amplitude of the bending moment divided by same Z. Z is going to be same. So which is Our amplitude bending moment is 200 Newton meter. So if I convert that one into Newton mm, it is 200 into 10 cube divided by 5 by 32 d cube. Then I'll calculate mean torsional shear stress. That is nothing but E mean divided by ZP, where ZP is polar section modulus of the shaft. So now, if I substitute the values for this TM and ZP, we got mean torque as 135 Newton meter. So again, I need to convert this one into Newton mm. I'll get 135 into 10 cube divided by ZP is nothing but 5 by 16 into D cube. Then similarly, I'll compute tau A. Tau A is nothing but amplitude of the torque divided by say ZP, polar section modulus, which is TA is 65 Newton meter. So if I convert that one into Newton mm, 65 into 10 cube divided by ZP is same 5 by 16 into D cube. Right? So now, from these two expressions, I have mean stress, mean normal stress and mean shear stress, amplitude normal stress and amplitude shear stress. Now I use this formula to find out equivalent normal stress and equivalent mean normal stress because of this mean normal stress and mean shear stress. So that means what I can write it here, sigma m equivalent. So that means I am finding out the equivalent mean stress due to this bending stress and due to this shear stress. So which is nothing but the formula for that is just now here, that is your sigma m whole square plus 3 into term square under square root. So you substitute that values, whatever values you got it here, you need to substitute here and you need to compute that. Similarly, I'll compute what is sigma A equivalent. The equivalent amplitude stress, that is the equivalent of this amplitude normal amplitude stress and shear amplitude stress. The same thing, same formula will use. That is sigma A whole square plus 3 into tau A square under square root. So now you got all these things. Once you have equivalent mean stress and equivalent amplitude stress, so that means the equivalent mean stress and equivalent amplitude stress is nothing but the equivalent of or equivalent normal stress and the amplitude reduced by combiningly acting this bending moment and twisting moment. So that's it. So that means if I have this one, then my equations for solving will go for again Goodman's equation. So in Goodman equation, what is our Goodman equation? Sigma m equivalent divided by plus sigma a. Here only thing is earlier we written sigma m and sigma a. Now we will write equivalent. Sigma m equivalent, sigma a equivalent. So that is the only thing you need to consider here. It is equal to 1 by fs. Also, you need to use sigma a equivalent divided by sigma m equivalent. So we have to take that also. That is, this is the low line equation. So from this you can take the relation between these two and substitute into this equation. You can solve it. So now in the equations your only d is going to be the unknown. If you substitute that and if you solve that, you get the d value. Okay, so this is how we can solve that. So now you tell me that you do the calculation, you tell me what is 1 by 1. We'll substitute these values there and we'll calculate these also. So now you tell me first this value, what is sigma m value? What is sigma m? Nobody is doing the calculations?
Sir,
Yeah, tell me.
six into 10 cube by d cube, sir.
Sigma m is 40 74.37 into 10 cube
Divided
divided
by d
by
cube.
d cube, which is in terms of Newton per mm square only.
And yes, sir.
Then sigma A
2037
2037.18
into
into
10
10
cube by d
cube
cube.
divided by d cube. Again, units are Newton per mm
Yes,
square. Then tau m is 687
687.54 into 10 cube.
687.55 into 10 cube divided by d cube. This one, tau A. Of course, here I don't have space. That's why I'm not writing the units. But you need to write the units.
331, sir.
331.04
04 into 10 cube by d cube.
into 10 cube divided by d cube.
D cube.
Okay. Now, you substitute sigma tau m here and you tell me what is sigma m equivalent. That is, you have to take square of this
1026.
plus 3 times square of this.
Sir, 10262.307. 10262.307.
After 4 to double 4
4828.6.
10 cube by
D cube.
Newton per mm square.
Sir.
And the sigma A equivalent you are going to get as 2116.33 into 10 cube divided by d cube Newton per mm square. You check whether we are getting these values or not.
42.
So once you got these two values, substitute into this equation. SUD is given, SUD is 540, SE is also given. No need to compute anything, no need to apply any factors here. He has given the entrance limit of the component itself. Directly he has given, take this one 200, 540 and 200. Substitute into this equation and try to solve for the D. Okay, I will jump off here. You don't have required any data, no more. Okay, 540, 200 is required. Anyway, I'll rub this. So, what is the first one? Tan theta is sigma A by sigma m. Your sigma A by sigma m. Of course, these two are equivalents. You need to consider equivalents only. Which is 4244. Sorry, sigma A is 2166. 2116, not double six. 2116.33 into 10 cube divided by 4244.84 into 10 cube. So 10 cube will cancel out. What you are going to get it as? 0.4986. Okay, anyway, so here you take 0.94986. So only thing is from this you need to calculate what is theta. So based on that you can identify whether your design point lies on your Goodman's line or maybe on lead line. So once you've done that, then use this equation to solve for the diameter D. So what is your sigma M? Again this 4244.84 into 10 cube divided by D cube into SUD is 540 plus your sigma A is 2116.33 into 10 cube divided by D cube into SE given it as 200 is equal to factor of safety 1 by factor of safety 1 by 2. So solve this equation. From this you will get D value. So now I will conclude that one and tell me what is the answer. Surya? Roll number 1. ఉన్నావమ్మా క్లాస్లో?
సార్ ఎస్ సార్
క్యాలిక్యులేషన్ చేస్తున్నావా?
చేస్తున్నాను సార్ చేస్తున్నాను సార్. అంటే కొంచెం ఇష్యూ వల్ల బోర్డు ఇందాక దాకా సరిగ్గా కనిపించలేదు సార్. అది ఫ్రెండ్ అడిగి నోట్ చేసుకున్నాను సార్.
బోర్డు కనిపించలేదా?
బ్లర్గా ఉంది సార్. అంటే నాకు నెట్వర్క్ ఇష్యూ ఉంది నాకు అనుకుంటా సార్.
నాకు కూడా కొంచెం బ్లర్ గా
ఎవరు నంబర్ ఎంత ఉంది?
13 సార్.
మరి ఇప్పుడు ఏం చేస్తున్నారు? బ్లర్ ఉంటే ఏం చేస్తున్నా చెప్పాలి కదా. ఇందాక నేను అడిగినప్పుడు బాగానే ఉంది, అంతా బాగానే ఉందని చెప్పారు కదా.
కొంచెం సార్ ఎక్కువ
అనుకుని వేరే వాళ్ళు
ఎక్కువ తక్కువ నాకు అర్థం కాదు.
నెట్ స్పీడ్ తగ్గినప్పుడు క్లారిటీ తగ్గుతుంది సార్. మళ్ళీ నెట్ స్పీడ్ వచ్చిన క్లారిటీ వస్తుంది సార్. జరుగుతుంది. నెట్ స్పీడ్ తగ్గినప్పుడు క్లారిటీ పోతుంది సార్. నెట్ స్పీడ్ వచ్చినప్పుడు మళ్ళీ క్లారిటీ వస్తుంది సార్. అలా వస్తుంది.
ఓకే ఓకే. సో డూ ద క్యాలిక్యులేషన్స్. క్యాలిక్యులేషన్ చేసి ఆన్సర్ చెప్పండి. ఎవడో ఒకటి చేస్తాడు, ఒకటే చేస్తాడు. ఎల్ఈపై ఒకడే ఎవడో ఏం చేయట్లా. అడిగినా కూడా ఎవరు సమాధానం చెప్పట్లా. మిగతా వాళ్ళంతా సైలెంట్ కూర్చుంటారు. అంటే క్యాలిక్యులేటర్ లేదు, ఏ లేదు. వీడియో చెప్తున్నారు నాకు బ్లర్ కొని పడుతుంది సార్ అది కానీ. మరి బ్లర్ కనిపించినప్పుడు ఏం చేద్దాం? చెప్పాలి కదా ముందే. నాకు సరిగ్గా క్లారిటీ లేదు సార్ అని క్వశ్చన్ అడిగితే అప్పుడు బ్లర్ కనిపిస్తుంది సార్ నాకని చెప్పారు.
కాదు సార్, ప్రాబ్లం నాకని నేను చెప్పలేదు సార్ అసలు.
ఓకే ఓకే, నో ప్రాబ్లం. సో క్యారీ ఆన్, క్యాలిక్యులేషన్ చేయి. అట్లానే ఇంకోటి వన్ మోర్ థింగ్, మీరు నాకంటే ముందుగా క్లాస్లో జాయిన్ అవుతారు కదా అప్పుడప్పుడు. ఏమవుతుందంటే ఇక్కడ ఇష్యూ రికార్డెడ్ వీడియో మీ గూగుల్ డ్రైవ్లో సేవ్ అవుతుంది. అట్లా కొన్ని క్లాసులు నాకు రాలేదు, రికార్డెడ్ వీడియోస్ నా దగ్గర లేవు. మీ ఎవరైతే ఒకసారి మీ గూగుల్ డ్రైవ్ చూసుకొని మీ దగ్గర రికార్డ్ అయిన వీడియో ఉంటే దాన్ని నా మెయిల్కి ఫార్వర్డ్ చేయండి. మేబీ 15 ఉంది కదా తేజ, వాడు ఒక రోజు లాగిన్ అయ్యాడు అందరికంటే ముందు. మేబీ అందరికంటే కాదు, నాకంటే ముందు లాగిన్ అయ్యాడు. వీడియో వాడి దగ్గర ఉంది, నేను డౌన్లోడ్ చేయడానికి నాకు ఆప్షన్ రావట్లా. ఒకసారి చెక్ చేసుకోండి మీ డ్రైవ్ లో. మన DM1 సబ్జెక్ట్ కి సంబంధించిన వీడియోస్ ఏమైనా ఉంటే ఫార్వర్డ్ చేయండి లేదా షేర్ చేయండి. షేర్ చేసినా ఓకే, ఇదర్ యూ కెన్ షేర్ ఇట్ ఆర్ యూ కెన్ ఫార్వర్డ్ ఇట్. అందరూ సో ఒకసారి చెక్ చేయండి. ఎవరెవరికి అయితే మీకు వీడియోస్ మీ దాంట్లో సేవ్ అయిందో యూ జస్ట్ ఫార్వర్డ్ ఇట్ టు మీ ఆర్ షేర్ ఇట్ టు మీ.
సార్ డి వాల్యూ 34.71 వచ్చింది సార్. డి వాల్యూ సార్
ఎంత
34.71 వచ్చింది సార్.
34
ఎస్ సార్.
33 వచ్చింది సార్.
33.29 వచ్చింది.
సార్ 33 పాయింట్
మేబీ రౌండ్ ఆఫ్ చేసిన కాడంగా తేడా వచ్చి ఉండదు. In that it is a solved problem only. So in the textbook he got 33.29. Maybe 34 is also okay. No issue. 34 also correct. Maybe we might have rounded off some values here somewhere. All these things there is a rounding of the numbers is there throughout. So 34 is also okay.
ఓకే సార్.
So now we have any doubt in this one. So I think with this we will close this topic, fluctuating stresses. Maybe in the next class we'll go for riveted joints. Maybe whatever problem I have given to you in yesterday's class and ask you to solve that problem. If you have any doubts or any queries in that problem, maybe tomorrow we have a discussion class. One discussion class is there. In that class we are going to discuss about the problem. If everybody is having a doubt, then I'll tell you the solution answer. If only those of you solve the problem, if you have only small doubts are there, then I will clarify those doubts. Otherwise, we will try to see a complete solution for the problem if required. So you tell me, so far in all these things, so especially not only in this problem, in any problem or any topic, so far whatever we discussed, if you have any doubt now, then you can raise your doubt because we have 5 more minutes time is there. So I cannot go for one more problem because within this 5 minutes. So if you have any doubt, now you can ask your doubts, clarification, anything up to whatever we covered. So first 2 units I think. So with this, the second unit is also completed. So if you have any doubt, then you can ask now. Maybe your mid examinations may be from the next week or after that week. I don't know exactly what is the schedule. So for that mid, you have this 2 unit syllabus. Those who are not prepared or who are not followed the class, try to do that right now. So start today itself. Otherwise, it is going to be difficult to perform in the examination. So because while teaching it or while reading this, you say that, oh, this is that much easy, like that you will feel. Subject is very easy. But while taking up the problem, if you want to solve the problem, then only you can understand the real difficulty. So most of you, I don't know, most of you using the data book or not, or most of you calculating these calculations or not. See, one simple thing I'll tell you. If you ignore everything now, so during the examination, even you cannot calculate a simple equation also. Data is calculate d5 you cannot do that. You are not able to do that. Definitely is failure. Try to change definitely failure. So don't take anything is light or easy. So try to take up some problems and try to solve that. If you want, I'll provide you some. I think I already placed that in that classroom practice problems. Maybe I posted previous old question papers for our reference. If you go through that classroom, that is there. Last 3 years papers are I posted there. You can go through those papers also, so that you get some idea what kind of problems are coming in the examination. So based on that, you may prepare better preparation may be there. Not only that, you take any one textbook and try to solve some more problems also. So nobody is asking doubt. Then what I do is,
సార్ అక్కడ tan theta ఎందుకు కనుక్కున్నాం సార్ అక్కడ?
tan theta ఎందుకు కనుక్కున్నాం? Okay, right. So we discussed about this modified Goodman diagram, right? This is right here, it is visible. Okay, right. So here, our modified Goodman diagram is. Okay, I'll take something. It will go. Okay. So here, SE is there for me. I need to join SE to SUD. That is our original Goodman diagram. Then extend this, and if I draw the yield line, so then this is the intersection point. So So here, this is the actual your modified Goodman diagram. Or if your design point lies within this range, so it is satisfying both the conditions. It is satisfying the Goodman criteria as well as yielding criteria. Here, to know that here why we are calculating, your question is why we are calculating the theta value here. So now, if I construct the diagram, so if I know the theta from this zero line, I will draw this line something like this. This is theta. So now, by taking this, see here it is intersecting here. It is intersecting here means it is intersecting the Goodman's line but not intersecting the yield line. If you know theta value, so let us say here in this particular problem, I think we got it as around 26.5 degrees. So for 20, if I take the 26.5 degrees and if I draw a line here, it will intersect the Goodman line. So that means only this equation, whatever equation we write, that first equation, this equation is sufficient to solve the problem because the failure is dictated by only this Goodman line. Or suppose you got theta value such that if you draw the load line, if it is passes somewhere something like this here. So now where it is intersecting, this is the theta value for this case, it is intersecting the yield line. Now you have to make use of the second equation also. The importance of this theta is it will tell you where your design point is there, whether your design point is intersecting the Goodman's line or the yield line. So that you know only if you draw the diagram. Without drawing the diagram, you cannot know that. So that's why what we are doing is we are using these two equations. We are using these two equations. If I draw the line graphically, if I draw for the theta, if I take the exact theta value, if I draw it, then only I can know that here whether my design point is on the Goodman line or it is intersecting both yield line as well as Goodman line. So to know that, you have to calculate this tan theta. We are not solving the problem graphically here. So then what we are doing here? Calculating this sigma m ratio, and in this equation we are substituting the value here. The ratio. That means I will replace sigma m by sigma a by tan theta or sigma a by sigma m tan theta. So that means I am substituting this instead of solving by graphical way. I am substituting this into this equation means I am doing it by analytical way. So then that is the importance. Clear?
Okay, sir. Thank you, sir.
So only thing is the intersection point Goodman line మీద ఉందా yield line మీద ఉందా ఐడెంటిఫై చేయడానికి you need to draw the load line. Suppose if it is intersected on the Goodman line, then second equation you use చేయక్కర్లేదు కూడా. So straight away you use only the first equation, that is sufficient. అలా కాకుండా suppose what I have drawn, second line I have drawn, if it is intersecting both your Goodman's line and yield line, so then your second equation is also important. So you know that only after drawing the Goodman diagram only you know. Graphically if you construct the diagram and if you draw the line with the theta whatever you got, then only you can do that. But while solving the problem, we don't know whether it is intersecting the yield line or whether it is intersecting the Goodman's line. So then to accommodate the yielding failure, we have to use this equation. That is the only thing. Maybe most of the cases you get the same thing. That means, so whatever, whether you substitute this relation or not, by substituting this ratio, you solve the d value. Without substituting that value also, you solve the d value. Both the cases, if you get the d value is same, that means that your what do you say, that load line is intersecting on the Goodman line only, not on this. That means you don't have any influence. So that means that is the first case. If it has an influence only in this case, if your theta is such that it is intersecting the yield line. If it is intersecting the Goodman's line, it doesn't matter whether you use this relation or not. If you use it or without using that also, you will get the same answer. Clear? No response. I don't know whether you understand it or not.
Yes, sir. అర్థమైంది సార్.
Okay, then okay. now I'm closing the class. So with this, we'll close this topic. Okay, in next class, we'll move on to the activity. Maybe if you have any doubt now, at least you prepare for that discussion class to ask some doubts. So, ఏం డౌట్ లేవు సైలెంట్ అంటే ఏ రానట్టు I can understand like that. మీరు క్వశ్చన్స్ అడగకుండా డౌట్స్ అడగకుండా సైలెంట్గా ఉన్నారంటే ఏంటంటే ఏం అర్థం కావట్లేదు మీకు ఆర్ యు ఆర్ నాట్ ఫాలోయింగ్ ఎనీథింగ్. సో మీరు దాని మీద కాన్సన్ట్రేట్ చేసి దాన్ని ఏది వినలేదు అంటే డెఫినెట్లీ డౌట్లు వస్తాయి. సో డౌట్ ఏం రాలేదంటే ఏంటంటే యు ఆర్ నాట్ ఫాలోయింగ్ ద క్లాస్. ఐ విల్ అజ్యూమ్ లైక్ దట్. ఎనీవే సో దట్ ఈస్ ఇంపార్టెంట్ థింగ్. సో లైక్ ఆల్రెడీ అన్నా మీకు ఎవరికైతే మీ గూగుల్ డ్రైవ్లో వీడియోస్ సేవ్ అయ్యాయో ఈ క్లాస్ సంబంధించి అవన్నీ వీడియోస్ ఇండివిజువల్గా నాకు షేర్ చేయండి లేదా ఫార్వర్డ్ చేయండి. సో వీ నీడ్ టు డౌన్లోడ్ దెమ్ అండ్ వీ నీడ్ టు పుట్ దెమ్ యాజ్ ఏ సంథింగ్ లైక్ ఏ డేటాబేస్ ఇన్ ద కాలేజ్. సో డూ దట్ ఎట్ ద ఎండ్ ఆఫ్ ద క్లాస్. క్లాస్ అయిపోయిన తర్వాత ఒకసారి చెక్ చేయండి మీ డ్రైవ్. మేబీ ఈ 54 ఉంది కదా, ఆల్మోస్ట్ వాళ్ళు ఫార్వర్డ్ చేసినట్టు ఉండు 54. మేబీ స్టిల్ సమ్ మోర్ వీడియోస్ ఐ am missing. I got only around, we have 30 classes we completed, but out of that I have only 20 videos with me, so 10 is missing. So you check all your drives, then share your videos from the Google Drive, right? Anyway, so right now, right, I'm closing the class now.